Okay, so factoring isn't so bad as long as you're doing one little section at a time and you're doing the same section over and over again. But what happens when you get to the test and it's all thrown together and you've got to decide looking at a polynomial and you're just told to factor it. So what are you going to do? So this section is just a general factoring strategy. This is the way, your brain should sort of be working as you're looking at these problems. Which way am I going to factor it? What's the best way to factor it? Or where do I even get started? So if you just sort of memorize these little steps here, then this will help you very much when it comes to test or when you're just thrown something and you've got to factor it. But first, of course, our joke of the day. Why does nobody talk to circles? Because there is no point. Okay, so factoring is all based on sort of like what to do depending on however many terms that you have. But first and foremost here, you are always, always, always going to look for that GCF, the common factor. So we always want to say, well, let's just try our best to reduce this thing as much as possible so that we're not having to deal with bigger numbers or anything. We just want to try to make it as simple as possible. And so we're always, always, always looking for a GCF. So that's your first step. Then it all depends on the number of terms. So I've sort of broken this up into 2 terms, 3 terms, and then 4 terms. So if you're given a 2-term polynomial, remember you are looking at the difference of the 2 squares. So a squared minus b squared, and that will factor into a plus b times a minus b. So what you're going to look for there, do I have, if it's got 2 terms, do I have perfect squares on both sides? And then what's the other requirement? Is that it must have a minus sign. Okay, so in this example, x squared minus 36, 2 terms. So go down your checklist, 2 terms, perfect squares on both sides, yes, and a minus in the middle. Yes, so that should factor x plus 6, x minus 6. Okay, so then what if it has 3 terms? Maybe I should do each one in a different color. If I have 3 terms, well, we learned 2 different forms of that. So the first form that we learned is a squared plus bx plus c, where this x squared term had a coefficient of just 1. Little imaginary 1 there. Whoops. 1. Okay. And so then we said what times what is equal to the c term that adds up to be that b term. So for example, let's see if I can find one here real quick. X squared plus 7x plus 10. We said what times what is 10 that adds up to be 7? Well, that would be 5 times 2 is 10 and 5 plus 2 is 7. So we would know this factors into x plus 5, x plus 2. Okay. And I know, I've had several students before who, they just fall in love with the big X method, like I told you might, and so they're still going to do big X on here, and that's perfectly fine because it works all the time. So it works on both of these forms. So the other form was where we did have a number in front of that X squared. You had that coefficient in front of there, and so we had to take that one into consideration. So we either did let me change colors so it's a different factoring method. The big X method, or we did our slide and divide method. So big X again was a times c, b term divide by a. Slide and divide. You went ax squared plus bx plus c. You slid that a down, creating this. And we came up with the factors and then divided by a. Okay, so let's find an example of that. I think this one works. 5y squared minus 17y plus 6. Well, you know I'm going to do big X. You can follow along doing your slide and divide. 5 times 6 is 30. Adds up to be a negative 17. Come divide by the a term, which is 5. So that makes negative 2 times negative 15. And then we would write our binomials. It doesn't reduce, so that one moves to the front. So 5x minus 2. This one reduces to a negative 3. Oh, that's y. Sorry. I'm so used to writing. 5y minus 2, and then y minus 3 for this one. So that would be using that big X method. All right, so then the last one was if it had 4 terms, which is actually the first one that we learned. Okay, so here we go. Let's back up. First, GCF, right? 2 terms, you're looking at the difference of 2 squares. If it's got 3 terms, you're looking at factoring it using the big X or using what times what is C that adds up to be B. The last one is your grouping. So remember how we did that? It's been a little while since that was a few videos ago. Let me see, I don't have. I have my sheet on grouping. Let's do this one. 3x cubed minus 2x squared minus 6x plus 4. Remember, we split this in 2, and we said, what's the GCF of these two? Which would be an x squared. What's the GCF of these two? The leading coefficient is negative, so we're going to take out a negative 2. We would take out the x squared out of the first 2 terms, leaving us with 3x minus 2. And then we take out the negative 2 out of those last 2 terms, which leaves us with 3x minus 2. Then we take out that common binomial, 3x minus 2 times x squared minus 2. And whenever I see this, I'm always going to look and see, because I have an x squared there, can it factor some more? So I've got 2 terms there, but 2 is not a perfect square, so that cannot be factored anymore, so that would be your final answer. But always watch for that, just in case anytime you have something like that x squared or anything higher than just an x left over, make sure you cannot continue to factor it. So hopefully this is helpful, just going over all the different terms that we, or the different ways that we learn to factor. And it all just, once you do your GCF, then the next thing you do is just look at the number of terms and learn how to factor from there. So hopefully it's helpful when it comes to your exams. Thanks.